welcome to channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your chemistry for class 11, that is your class 27. We had done your 26th class in the last session, and that will be continuing here. In 26th class, where we had discussed about the important trends and anomalies properties of boron as well. That is the last topic. So on the same way, we'll start discussing about it. We'll continue with the unit 11, which is the P-block elements, and so let's go for it. And that is your unit 11, the P-block elements. Okay, so this is your P-block elements here. In the same way, we'll continue with the same, that this topic will be starting here as your some important compounds of boron. So here we go for it. That is the detail. We'll discuss about the orthoboric acid as well as for the diborane and many more with their structures as well. So here we go for it. So some important compounds of boron. In terms of some important compounds of boron that will be going to discuss here. So for that, some useful compounds of boron that are borax, orthoric acid, and diborate. We'll be briefly study their chemistry. First, we'll discuss about in the detail about the borax here. The first one. Borax. Okay. So in terms of borax here, which we have to discuss about it. So in terms of borax, it is important compound of boron, and it is a white crystalline solid of formula, where the formula for the same, it will be Na2 B4O7.10H2O. This is the formula of borax, which is Na2B4 and your O7.10H2O. In fact, it contains the tetranuclear unit, which is your B4O5OH4 3 minus. So for the here in the scene, which is of 2 minus here, which is B4O5OH twice 2 minus, that is we have to discuss here. Okay, so this is basically it contains the tetranuclear units, and that is the correct formula for therefore is Na2B4O5OH2.10H2. I will just write it down for that. It will be Na2B4O5OH4 8H2 here. In that borax is dissolved in water to give an alkaline solution, which is Na2B4O7 plus 7H2O, which will give you 2NaOH plus 4H3BO3, which is your orthoboric acid. So basically it is orthoboric acid, and that is the formula here. On heating, the borax first loses water molecules and swells up. On a further heating, it turns into a transparent liquid which solidifies into a glass-like material that has been known as your borax bead. In the same way, we'll be having an equation where we'll find out the sodium metaborate and your boron anhydride, and that we have is your Na2B4O7.10H2O, which having containing the water molecule as well. In the presence of heat, it will be evaluated Na2B4O7. that is named as sodium metaborate. And in the presence of further heat, it will give you 2NeBO2 plus B2O3, which is your boric anhydride. That metal borate of many transitions metals that have characteristics, colors, and therefore borax bead test that can be used to identify that in the laboratory. For example, when the borax heated in a Bunsen burner flame with CaO and on a loop of platinum wire, a blue color COPO2 whole twice bead is formed. Now we'll discuss about the second one, which is orthoboric acid. In terms of orthoboric acid here, that is the orthoboric acid, it is your H3BO3. So in H3BO3, that is the orthoboric acid here, and is a white crystalline solid with soapy touch and it is sparingly solutions in water but highly soluble in hot water. It can be prepared by acidifying an aqueous solutions of borax, where we have an equation for the same, which is your Na2B4O7 plus 2HCl plus 5H2O will give 2NaCl plus 4BOH thrice. Okay. So it also formed by anhydrolysis, which is the reaction with water or dilute acid of most boron compound like halides, hydrides, etc. It has a layer structures in which planar BO3 units joined by hydrogen bond as will be joined. And boric acid is a weak monobasic acid. It is not a protonic acid but acts as Lewis acid by accepting electrons from the hydroxyl ion, which is BOH thrice plus 2HOH, which is 2H2O, will give BOH twice 4 plus H3O plus. On heating, orthoboric acid above 370 Kelvin forms a metaboric acid, which is SbO3, and which on further heating yields boric oxide, which is B2O3, which is your H3BO3. Then heat HBO2 on further heat B2O3. This is how it forms. Now coming towards for the structure that we have for the structures of boric acid. HOB so we found So this H bond. So this is the structure that we have. Okay. So this is the structure for, I just write it down for you. Structure of boric acid. The dotted lines represent hydrogen bond. Okay, so this is the structure that is being formed. Now we'll go for it and further we'll discuss the question here. The question in terms of orthoboric acid and borax in terms of it. So yes, we have a question which is, why is boric acid considered as a weak acid? That is the question. So you will have to answer it out on the same. So let's go for the same. So the question is, why is boric acid considered as a weak acid? So, because it is not able to release hydrogen plus ions and on its own, and it receives OH minus ions from a water molecule to complete its octet, and it turns release H plus ions. Because it is not able to release H plus ions on its own, it receives OH minus ions from water molecule to complete the octet, and in turn release H plus ions. Okay, this is the boric acid that is being considered as a weak acid. Now we'll discuss about the diborane, that is we'll discuss in the next coming class because it will be extended. So here we're gonna end up with please like, share and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Other than this, we are dealing with the chemistry part 1 we had done, and physics as well as we are dealing here in terms of it, and other than this as well, if I'm going ahead in terms of chemistry part 2, we had part 1 we had completed some basic concepts of chemistry, structures of atom, classifications of elements and periodicity of your properties, chemical bonding and molecular structure, states of matter, thermodynamics, and the fourth one is your electronegativity, equilibrium. In terms of unit A, which is your redox reaction, hydrogen, the P-block element, that is the 10th unit. In 11th unit we have covered up the P-block element. 12 is your organic chemistry, some basic principles and technique. Unit 13 is your hydrocarbons, and unit 14 is your environmental chemistry. That's what we have to cover up. So here we're gonna end up with. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.